I'm Anil Kumar. Welcome to our YouTube channel and the website globalmathinstitute.com. Let me thank all the viewers and subscribers for watching my videos and posting brilliant questions. I do have an email ID which is right there. For your request, you can always send the questions on this particular email. Now, here is a brilliant question from one of our subscribers who wants to understand the concepts of rotation, especially when it is a point outside the figure, and also when the point is not at the origin. So, we have a question here where we look into clockwise and counterclockwise rotation about an external point which is not even at the origin. So that is slightly challenging. So the question here is it is a test question based on rotation of 90 degrees about an external point. You are given an object A which is shown here in green. Rotate object A 90 degrees clockwise about 10 and label it P. Rotate object A 90 degrees counterclockwise about -10 and label it Q. Describe the transformation from P to Q. That is part C. And part D is describe the rotation from P to Q. So these are the four related questions. I'd like you to pause the video, answer the question, and then look into my suggestions. Now, for benefit of most viewers, I'll begin by giving a background on rotation about 90 degrees through origin, right? So let's say we have 90 degrees counterclockwise, that is counterclockwise rotation about origin. Let's say we have this question. Let me call this as example 1. So let me just draw an object. I'll take a very simple object. Let us say we begin from here and we go one space and one more space, three spaces, let us say. And I draw a line from this place to that place, right? So let's say this is the origin O, and then we have some point given right there, right? So let's say we call this point as S. Now, if I have to rotate it counterclockwise, 90 degrees, then how will this line OS look like? That is what we should be looking at. Now, since we are rotating about the origin itself, what really happens is that the coordinate points, let me now make a coordinate axis. Let's say this is 1, this is 2, that is 3. So we'll keep this as, let's say 1. Let's label this as -1. And here that will be -1. Correct. So the coordinates of point S for us now will be the x coordinate is 3 and y coordinate is 1. So when you want to rotate it counterclockwise 90 degrees, that means a rotation which can be shown as like this, right? That is the kind of rotation, right? Counterclockwise by 90 degrees. Now what really happens is that the coordinate points, let's say it is rotated, it will get transformed to, let's say, t, where these coordinates will flip. So it will become 1 and 3. Secondly, when you rotate, that 1 becomes negative. So it will be -1 and 3. So what really happens is that if you have x and y coordinates, in that case, they will be transformed. And what you get is -y and x. So these are the new coordinates when you do counterclockwise by 90 degrees. Is this concept clear? So if I do that, instead of 3, 1, it becomes -1 and then 3. So 1, 2, and 3. So that becomes the position of this particular point. And now I can actually show it by an arrow starting from origin to this particular point. And let me call this as T. So we can say that OS has been rotated by 90 degrees counterclockwise. So this is what we call 90 degrees counterclockwise rotation. Correct? In case you want to do it clockwise 90 degrees, then what will happen? Well, they still swap. So let's say we have a point U. So from S, we are going to U. However, this time we are going 90 degrees clockwise. So in that case, what really happens is the coordinates still swap, but this time the y coordinate becomes negative. Since when you come to the other side, let us say, when you're on this side, in that case, you see the y coordinates are negative, right? So here, the transformation will be that x and y values will swap, right? But this value, which corresponds to the y value, will be negative. So the point will be 1 minus 3. So we go 1 here and then 1, 2, and 3. So that becomes the final position, and we can actually sketch this line, which is kind of like this. So we get a point which is u for us, right? The coordinates for u will be 1 minus 3. Do you see that? So when you do counterclockwise, then the x value becomes negative since you are coming from quadrant 1 to quadrant 2. But when you do clockwise rotation, you land in quadrant 4 in which the y coordinate is negative. So you swap and make the y coordinate negative. That is one part. So I think that will help you to answer the first and the second question. Now we're talking about the description, right? Now clearly what you see here is 180 degrees rotation. Do you see that? So what we have here is a rotation by 180 degrees. So overall it is a rotation by 180 degrees. You can go either side. So when you do a clockwise rotation and a counterclockwise rotation, net result will be some way or the other a 180 degrees rotation. Perfect. So that is one way of looking at it. The other way is it could also be treated as a reflection, correct? So you could actually think about it as a reflection of this particular line on x-axis and then y-axis. So 180 degrees rotation, or you could also say reflection on x-axis and y-axis of the two image which you see from here, right? So that is how the images are related. So I hope you're getting the concept, and this should answer the transformation part, right? Which is 180 degrees, and also the rotation part. So this is your basic concept about rotation. But we have taken a simple example. We have rotated about the origin. The question says you need to rotate about some other point, not the origin. The point here is 1, 0 and minus 1, 0. However, the same concept can be applied. So I'd like you to pause the video and answer this particular question. I'll take up this solution on the next page. Now, let us try to answer this particular question, which is a test question for us. Rotation of 90 degrees about an external point. We are given the object A as shown here. We need to rotate object A 90 degrees clockwise about 1, 0 and label it P, right? So let's identify where the point is. 1, 0 is right there. So that is our new origin. I'll call this as O dash. So we'll use this as our origin, right? We are going to rotate about this particular point. Let me label some important points on this particular figure also. So we'll say this, let this be the point A for us, this point be B for us, let it be C, and we'll take this as D, right? And here we'll take this as E. Okay. So we have these points on the object A. We'll try to see the coordinates from the new coordinate plane, which is O for us. Do you get the idea, right? Since we know that when we look into 90 degrees clockwise, the transformation of the points will be if I have x and y values, let me write down at the bottom. So let's look in the transformation. So when we have 90 degrees clockwise rotation, in that case, a point which is x and y will actually get to the point which is, they will swap, right? So it become y and minus of x, correct? So that is how it will be. Let me write it on the right hand side. That will be better, since this portion we might just use. So let's say when we have 90 degrees clockwise rotation, then the points which are x and y will actually get to the image point as y and minus of x, right? So that should help us to get the new points. Now, for the point A, let's read the coordinates. So for A, the coordinates are with respect to the new origin, right? Do you see that? So we have the x values minus 1, 2, 3, 4. So we can write this as minus 4, and we have to go 1 unit up. Now this will get translated to the point A dash, that is the image, where 1 will swap and minus 4 becomes plus 4. So 1, 4 from origin A, O dash, right? So we'll go to 1, 4 from here. 1 is 1, right? And then we are going 1, 2, 3, 4. So that becomes the point A dash for us. Is this part clear, right? So what we have done here is we have identified new origin, which is O dash. So O dash is the new origin, which is the point 1, 0 itself. So whatever is your new point, which is the center of rotation or about that particular point, that now becomes a new origin for you. So check the points from that point, and so you get point A. Now, B coordinate values are from here, the x value is minus 4 as we have seen. The y value has increased from 1 to 2, 3 and 4. So it becomes minus 4, 4 from the new origin O, right? So let me write down B as minus 4, 4. So that changes to B dash. And the coordinates for B dash will be, we have 4 and 4. So 4 and 4 will be, from here we can go 3 more units to the right, right? So 1. So this is already from here 1, 2, 3 and 4, kind of the end of this, right? So we know it's a straight line. We can just connect them. So that is from A to B dash. Now we can actually complete our figure, and we know the other point, which is 2 units, 1 unit, because that is what E is. So from here we can say come down 2 units, we get C, right? So that is easy to form. So we can actually complete the diagram as shown here. Okay, let me just remove this. So we have already drawn the critical points. Now I think we can complete this as shown here, right? So that becomes our diagram. We'll call this rotated figure as P. So we'll call this as P. Let me write P here. Does it make sense to you? So that becomes the rotation of the given figure by 90 degrees clockwise. Perfect. So, 90 degrees clockwise. So that becomes the rotation. And so we can actually see that that is how they are related. You need to use a ruler for proper diagrams, right? So this is your 90 degrees, as you can see, and it is clockwise. Perfect. So we move from this place to that place. And we got our image P. Perfect. So we've done part A. Now let's do part B, which is rotating about another point, which is minus 1, 0. So minus 1, 0 is this now. So we are saying O double dash is our new origin, which is here at minus 1, 0. So we'll take up all these points from the new origin. Perfect. So from new origin, what are the coordinates for A? Now we'll take minus 1, 0 as new origin, which I'm saying O double dash, correct? As shown. Now from O double dash, what is the position of A? We have to move 2 units left. Now we have A, which we are moving 2 units left and 1 up. Now its rotation, we are doing the rotation which is 90 degrees counterclockwise, correct? From about point O dash, and point O dash is minus 1, 0. So this will swap, but this time, since you are doing it counterclockwise, in that case, the x value becomes negative, right? So it becomes A double dash will be 1 comes on this side, correct? So 1 comes on this side, and when you do that, then the y value will be minus 2, but the value of 1 now becomes minus 1, correct? Since we are doing a counterclockwise rotation, right? So let me first write down what the transformation is so that's simpler for you to understand. So in this particular case, if I have x and y point, in that case, it swaps to minus y since x is negative, right? X. That is how it swaps. So now let us take the point A, which from O dash is 2 units left and 1 unit up. So that will go to a new point, which is A double dash. So 1 and minus 2 swap. So we get this as minus 1 and minus 2. So the new point from here will be minus 1 is 1 unit there, right? And minus 2 means you have to come down 2 units. So 1, 2. So that will be the new point for A dash. Do you see that? So if you connect this, it makes sense. Do you see it is 90 degrees? And that is perfectly fine. That is how it should be. Now if you do that point B, so I'm calling that as B. So new point B, I shouldn't use, let's use this from the second coordinate. So B now from this particular point is at minus 2, but it is much higher at 4. So that changes to a new position. We call that at B double dash, where 4 comes on this side and becomes negative, right? So that is the new position. So we are already at 2. So now 3 and this 4. So that becomes the position of B. So from this particular point, 1, 2, 3, and 4, that will be the new position. So let me just join this. So this becomes B double dash for us. So rotating about O dash, that is what it is going to be. So when you rotate, that horizontal line will now become vertical. So it will look like this, right? So when you rotate this particular object, it is upwards, right? So when you rotate this particular object and it comes in this particular fashion, so B is coming like this. So point C will be above like this, correct? So you can now complete your figure and show it like this. So that is how the figure is going to be. So that becomes the new image, and we can call this as Q. Is that clear to you? Perfect. So basically, you could actually continue with all the points following this particular method, and you'll get the new points. So that is how you could actually sketch the particular diagram. Is that clear to you? Perfect. Now, let me summarize in a new diagram what we actually did, right? So in this particular case, what it did was we have 2 points. We have a point which is 1, 0. So we marked this point 1, 0, which is right there. And when we marked it 1, 0, we call this as a new origin, which is O dash, and this is at 1, 0. With reference to O dash, when we rotated, we came to a position which was at 1 from here 1 4 1 1 2 3 4, correct? And so we got an image which was kind of like this, and we are calling this as point P. Then the second time we started with the counterclockwise rotation, which was at minus 1 0, which is right here. So when we began with this, the new reflection was from here on this particular side, and since it is 1 2 1, so we went reverse direction. We went from here, instead of going 2, we went 1 here and 2 down, 1 2. That is because it is 90 degrees rotation. Do you see that part, right? And then we have drawn the complete image, which is kind of like this. Now let's look into part C, which is describe the transformation. You can see it is a reflection for sure, right? So you could reflect and then translate, you could do. So but for this part C, we can say it is reflection on, we can reflect it on y-axis. Then it comes on this particular side, and then we need to reflect it somehow to get over the image, right? So which is Q for us. Now to do that, we have to go midway between them. Perfect. Distance is 1, 2, 3, 4, 5, and 1, 6, right? So if I go midway, which is, let's say, right, 1, 2, 3, somewhere here, this line is y equals to 1. Everywhere on this line is y equals to 1. So we can reflect on y-axis and then on the horizontal line, y equals to 1. So that is how we could describe the rotation. So when we do that, we actually overlap these two. Now let's look into part D, which is describe the rotation from P to Q. So that is with reflections, correct? A transformation. Now let's do part D, which is about rotation. Now to find the rotation, the best way is to connect these 2 points. So if I connect these 2 points, let's say with a straight line, we notice that somewhere here we have a midpoint. And you can see that one image is a rotation of the other image by 180 degrees. Does make sense to you? So you see that this is a rotation by 180 degrees about a new point, which is right there. Is that clear to you? So we can describe this particular rotation as 180 degrees. It could be clockwise or it could be counterclockwise about, let me write counterclockwise since I've shown it like this. Is that clear to you? About a new point which from the origin is 0, 1. Is that clear to you? Perfect. So if you rotate about this particular point, the image P will overlap Q. And so you can describe rotation from P to Q. Does make sense to you, right? So that is how we could actually describe this particular rotation. I hope now the concept is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.